Debarking is the first step you can't skip when building a log cabin. Bark holds moisture, and leaving it on invites insects and fungal decay into the wood fibers. Proper debarking allows the logs to dry evenly, reducing cracks and long-term warping. Doing this right prepares the logs for treatment and structural assembly ahead. After debarking, the logs are sent to the sawmill and cut to the exact design dimensions. Every cut directly affects how the logs fit together and how the structure carries load. Accurate cutting ensures tight joints, even load distribution, and minimal adjustment during assembly. Any error here will carry through the entire build. Before permanent construction, a temporary foundation is laid using stacked bricks to establish level and layout. It's not meant for long-term load, but it must be flat and stable for accurate log measurements. Getting this right ensures precise cutting, joint layout, and test fitting to the design dimensions. Even small errors at this stage can throw the entire cabin out of alignment. When building the first floor joists, each timber is carefully measured and cut to fit with precision. Joist spacing and bearing points determine floor stiffness and long-term load capacity. Accurate cuts ensure even load transfer, preventing sagging and future noise. This structure directly supports everything built above it. The ground floor beams are one of the most important parts of a log cabin, as they bear both the static structural load and the dynamic load from daily activities. In an off-grid environment where humidity and temperature fluctuate significantly, selecting the correct timber cross-section and arranging the beams appropriately becomes even more crucial. The spacing between beams is usually calculated based on the span length, timber type, and expected load, to ensure the floor is sufficiently rigid without wasting material. Each beam needs to be precisely cut at the support point to transmit the force directly to the foundation, avoiding twisting or slippage over time. The joints between beams and end beams must be tight to limit micro-movements, the main cause of creaking and sagging of the floor after years of use. Additionally, raising the floor beams sufficiently above the ground helps reduce reverse moisture flow, extending the lifespan of the entire cabin structure. A properly constructed floor beam system will provide a solid foundation for all subsequent stages, from the log walls to the roof. After cutting and test fitting, the logs are sprayed with a yellow-tinted protective solution. This type of treatment is commonly used to penetrate the wood fibers and prevent insects and fungal growth from within. Applying it at this stage ensures full coverage, especially on cut ends and contact surfaces. It's a critical preventive step before the logs are permanently installed into the structure. After spraying the wood with a protective solution, they proceed to erect the ridge log. The ridge log is the central load-bearing element of the roof system in a traditional log cabin. Unlike modern frame houses that rely on steel trusses or purlins, the ridge log is typically a single solid timber, responsible for receiving the full load from the roof rafters and transferring it directly down to the two log walls below. This is why ridge log selection requires a large cross-section, straight grain, minimal knots, and stable moisture content. A properly installed ridge log must meet three key requirements: straight alignment, correct elevation, and solid bearing at both ends. If the beam sags or twists, roof loads become uneven, leading to wall settlement, joint cracking, or long-term roof deformation. In off-grid environments, where roofs face strong winds, prolonged rainfall, or heavy snow, the ridge log functions as the structural backbone of the cabin. Proper reinforcement at this stage ensures roof stability and significantly extends the lifespan of the entire log cabin. After the ridge log is securely set, the construction moves on to the loft beam system. Loft beams tie the two log walls together while supporting the loft floor and part of the roof load. In traditional log cabins, these beams are typically made from solid timbers or large section sawn wood, installed perpendicular to the building axis to transfer loads directly into the load-bearing walls. After completing the full system of beams and loft framing, the wood preparation reaches its final stage, preparing the roof posts and ridge beam components. At this point, each structural element is remeasured, bearing surfaces are refined, joints are cut, and installation positions are clearly marked. Standardizing dimensions at the workshop level allows for faster and more accurate assembly at the new building site. Roof posts and ridge beams are critical load-bearing elements, so the timber is carefully selected for cross-section size, grain quality, and structural stability. Cut ends and contact surfaces are often treated to reduce moisture absorption and splitting during transport. Once all components are prepared and clearly organized, the structure can be disassembled, packed, and transported to the new location, where the actual log cabin construction officially begins. After the components are transported and assembly begins at the new site, insulation is installed between the log courses using fiber material. This insulation is laid along the contact lines between logs, reducing heat loss and blocking air infiltration through the joints. In log cabin construction, this is a traditional yet highly effective method for maintaining stable indoor temperatures year-round. The insulation must be placed evenly without being overly compressed, allowing the material to retain its air-trapping properties. At the same time, it accommodates natural seasonal movement of the logs without opening gaps at the joints. When installed correctly, this insulation system improves air tightness, reduces heating demand, and significantly enhances comfort in off-grid living conditions. After completing the insulation between the log courses, the ground floor wooden posts are set onto the pre-poured foundation at the new site. These posts transfer vertical loads from the entire structure above directly into the foundation, so accurate positioning and elevation are critical. Before installation, post bases are typically treated against moisture and set on metal shoes or anchor bolts to prevent direct contact with concrete. Plumbing and aligning each post from the start ensures the structural frame works along its intended axis, reducing the risk of settlement or twisting later on. In off-grid conditions where repairs are labor-intensive, this step is especially critical. Properly set posts provide a solid base for the installation of floor beams and log walls that follow. After the ground floor posts are securely anchored to the foundation, the construction moves on to building the first floor logs. The first log course is critical as it establishes the elevation, orientation, and alignment of the entire structure. Each log is carefully placed on pre-marked positions, ensuring flat contact surfaces and precise bearing on the supports below. In log cabin construction, accuracy at the first floor determines the quality of everything built above. Any misalignment or unevenness at this level accumulates as the walls rise, leading to twisted walls and compromised joints. Getting this stage right allows the log walls to work evenly, transferring loads directly into the foundation and forming a stable base for the rest of the build. As the first floor log construction continues, each log is set directly onto the newly erected wooden post grid and the pre-built concrete columns and walls. This combination of timber posts and concrete supports helps distribute the first floor load evenly, reducing the structural span carried by each individual member. As a result, the logs work more efficiently and floor deflection is minimized over time. Precise alignment at each bearing point is critical. Contact surfaces must be flat and tight to ensure loads are transferred directly into the foundation, preventing localized stress concentrations. In this hybrid wood-concrete structure, proper execution results in a stiff, load-capable first floor that provides a solid base for the log cabin above. If you find this video interesting, please subscribe to our channel to support us. After the first floor framing is established, an additional support post is installed near the center of the house. Because the design includes a double-height living space, part of the floor is left open, preventing loads from being distributed in a conventional way. This support post collects loads from the surrounding beams and transfers them directly into the foundation. Proper placement of this post compensates for the missing floor area created by the open living space, keeping the remaining floor system stable. Without this support, floor beams would be prone to sagging and vibration over time. In off-grid log cabin design, a central support post allows for open, airy spaces while maintaining long-term structural safety. After the floor system and central support posts are stabilized, the wall framing for the first floor, also serving as the loft level, is erected. At this elevation, the wall frame functions both as an enclosure and as a primary support for the roof load, requiring higher precision and stronger connections than standard wall framing. Vertical posts and horizontal beams are aligned on axis to transfer loads directly into the floor system and supporting posts below. Because the loft level is heavily influenced by roof and wind loads, the connections must be rigid enough to resist vibration and twisting. Proper execution at this stage allows the walls to work in unison with the roof structure above, ensuring long-term stability of the log cabin in off-grid conditions. Once the wall lines and elevations are established, each wall frame is fully assembled on the ground and then lifted into position. This method allows precise control over squareness, alignment, and connection quality before working at height, significantly reducing installation errors. Each wall frame is designed with a large horizontal timber that will later directly support the roof beams. This horizontal member acts as a roof-bearing beam, collecting loads from the rafters and distributing them evenly into the vertical posts of the wall frame. If its size or placement is incorrect, roof loads can become concentrated and cause frame twisting. Pre-assembling and lifting the wall frames ensures the structure works correctly from the start, which is especially critical for log cabins with heavy roof systems in off-grid environments. After the wall frames and roof-bearing beams are properly set, a large roof window frame is installed into the structure. A roof window brings natural light deep into the loft space, but it also creates a structural interruption in the roof system. For this reason, the opening is reinforced with header beams and load transfer members to redirect forces around the window. The frame must be installed at the correct elevation, tightly sealed, and designed to allow for natural wood movement over time. If not handled properly, this area becomes prone to roof sagging or water intrusion. In off-grid log cabins, a well-executed roof window frame enhances livability while preserving the integrity of the roof structure. After the roof window frame is secured and all roof bearing points are prepared, the ridge beam is installed. The ridge beam sits at the highest point of the roof, where both roof planes meet, transferring the entire roof load down into the walls and posts below. In traditional log cabins, the ridge beam is typically a large, straight timber selected for its cross-section size and grain quality. Installing the ridge beam requires precise control of elevation and alignment, as even minor deviations can cause uneven load behavior in the roof system. When properly set, the ridge beam allows the rafters to distribute loads evenly to both sides, improving resistance to wind and snow. This step is critical to the long-term stability of the entire cabin roof. After the ridge beam is set at the correct elevation and securely fixed, the roof trusses are installed. These trusses span from the ridge beam down to the roof supports and wall frames, forming the primary load-bearing structure of the roof. The slope, spacing, and cross-section of each truss are carefully calculated to distribute roof loads evenly into the structure below. Each truss must be aligned on axis, seated firmly at bearing points, and securely connected to prevent twisting. Improper placement can lead to roof sagging or vibration under wind loads. In off-grid log cabins, a properly installed truss system ensures roof stability and prepares the structure for roofing and final finishes.
If you find this video interesting, please subscribe to our channel to support us. Once the entire roof truss system is installed and secured, roof decking is laid directly on top of the trusses. The wooden panels are fixed tightly together to form a strong, continuous surface across the entire roof area. This roof deck not only locks the truss system in place, but also helps distribute wind and snow loads evenly throughout the structure. The completed roof deck then serves as the base for installing the waterproof underlayment. This layer acts as a secondary moisture barrier, protecting the house in case the primary roofing material fails or when water accumulates on the roof surface. In off-grid log cabin construction, Properly installed roof decking is critical to achieving long-term water resistance and structural durability.
After the roof deck is fully installed and forms a continuous surface, roof ties are added. These ties prevent the two sides of the roof from being pushed outward under roof loads, while also stopping the walls from spreading over time. In timber roof structures, they play a critical role in controlling the horizontal forces generated by roof weight and wind. Properly positioned and securely connected roof ties create a closed structural system that keeps loads contained within the frame. If they are missing or incorrectly installed, log walls can gradually spread and compromise the building's stability. In off-grid log cabins, roof ties are essential for maintaining long-term structural integrity and overall rigidity.
Once the roof structure is fully completed and stabilized, the gutter system is installed. Its role is to collect and direct rainwater away from the roof in a controlled manner, preventing water from flowing directly onto the log walls and foundation. In log cabins, this small detail has a major impact on long-term durability. The gutters are installed with a precise slope to ensure fast drainage and prevent standing water, overflow, or backflow into the roof structure. When properly installed, the system protects the wood surfaces, reduces moisture damage, and prevents foundation erosion over time. After the gutter system and roof structure are fully prepared, the tile roofing begins. This is the outermost protective layer of the house, directly exposed to rain, wind, sun, and snow, and it plays a critical role in the building's weather resistance. Each tile is installed from the bottom upward with precise overlapping to ensure rainwater flows downward without penetrating the roof.
The weight of the tiles also adds stability, helping the underlying structure perform better under strong winds and long-term loads. In a log cabin, tiled roofing serves not only a technical function, but also defines the architectural proportion and sense of solidity. Once completed, the tiles, combined with the gutter system and roof bracing, form the final line of defense that protects the entire wooden structure for decades. Before installing the wood fiber boards, they build a secondary wall framing system using smaller vertical studs placed between the main structural posts. This system is not load-bearing, but it defines the wall layout and the interior spatial structure. The studs are carefully aligned and spaced to accurately form openings for windows, doors, and other technical installations. This framing also provides a solid fixing base for the wood fiber boards and later exterior finishes. They move on to finishing the ground floor walls using STEICO Universal 35 wood fiber boards with a thickness of 35 millimeters. This is a critical technical enclosure layer, providing both insulation and protection for the wooden structure during the next construction stages. These boards offer excellent thermal insulation, keeping the interior warm in winter and reducing heat gain during summer. At the same time, they function as an effective barrier against wind, rain, and dust, providing temporary weather protection before the final exterior cladding is installed. From an off-grid construction perspective, STEICO Universal 35 stands out for being made from natural wood fibers, making it environmentally friendly and recyclable. When installed correctly, this layer helps stabilize indoor temperatures, reduce energy consumption, and significantly extend the lifespan of the entire log cabin wall system. The first floor walls, also serving as the attic level, are covered with STEICO Universal 35 wood fiber boards, 35 millimeters thick. This creates a continuous building envelope across the upper part of the house. Once the secondary wall framing is complete, they begin filling the wall cavities with insulation, in this case, natural sheep wool. This is a common choice in off-grid construction due to its thermal performance and long-term durability. Sheep wool has a naturally crimped fiber structure that traps air, providing effective insulation in both winter and summer. More importantly, it can regulate moisture by absorbing and releasing water vapor without losing its insulating properties, keeping the wooden structure dry and stable. Compared to industrial insulation materials, sheep wool is environmentally friendly, non-irritating, and well-suited for traditional wooden buildings. When installed with the correct density, it creates a warm, resilient living environment, ideal for long-term off-grid log cabin use.
Once the attic-level walls are fully enclosed, they proceed to install the first-floor decking. This is a critical finishing step that creates the usable floor surface while locking the entire floor joist system beneath it. The floorboards are laid perpendicular to the joists, tightly fitted and securely fixed to ensure even load distribution across the structure. Precision at this stage determines how solid the floor feels underfoot and helps prevent vibration or long-term sagging. In a log cabin, the attic floor is not only a living space, but also a structural element that stiffens the entire frame. Once the flooring is completed, the building gains significant overall stability, preparing it for the next interior finishing stages.
The floorboards are installed with staggered joints, a standard technique in timber construction. This method provides not only visual balance, but also critical structural benefits. By avoiding continuous end joints in a single line, loads are distributed more evenly across the floor joists, resulting in a stronger and more stable floor system. Staggered joints also allow the wood to naturally expand and contract with changes in temperature and humidity, reducing the risk of gaps, shifting, or warping over time. If all joints were aligned, that line would become a structural weak point, prone to deflection or failure under heavy loads. In log cabin construction, where wood is always in motion, staggered flooring is essential for long-term durability and reliability. After completing the attic floor, they continue insulating the first floor attic area using natural sheep wool. The insulation is carefully packed into the framing cavities to eliminate gaps that could lead to heat loss. In attic spaces, where temperature fluctuations are the most severe, sheep wool performs exceptionally well due to its thermal retention and natural moisture regulation. It can absorb and release moisture without compromising its insulating properties, keeping the wooden structure stable. After completing the attic insulation, they proceed with installing secondary stud framing in the roof area. These smaller studs are aligned along the roof slope, forming the framework for the exterior enclosure. This secondary framing does not carry the main roof load, but it plays a critical role in securing the wood fiber boards, maintaining technical spacing, and ensuring a flat, even roof surface. It also helps compartmentalize the insulation, preventing material displacement over time.
After the secondary roof framing is in place, they insulate the roof using ecological insulation made from recycled hemp and jute fibers. This type of insulation is well suited for off-grid wooden buildings where natural performance and long-term durability are priorities. Hemp and jute fibers have a porous structure that traps air effectively, reducing heat loss in winter and limiting heat gain in summer. At the same time, these materials regulate moisture by allowing vapor to pass through, preventing condensation and protecting the roof's wooden structure from mold and decay. Using recycled natural fibers minimizes environmental impact and creates a healthy, non-toxic living space. When installed correctly, this insulation layer plays a key role in maintaining a stable indoor climate over many years. After completing the roof insulation, they install wood fiber boards to fully enclose the first floor, which also serves as the attic level. This is a critical step that officially seals the structural frame and completes the building's primary protective envelope. The wood fiber boards are installed tightly and continuously, forming a uniform enclosure across both walls and roof. This layer blocks wind, reduces rain penetration, and limits dust ingress, while still allowing the internal wooden structure to breathe and release moisture naturally. Once the frame is sealed, the building reaches a stable structural and thermal state. At this point, the log cabin is protected from direct weather exposure and ready for interior finishing and final exterior cladding.
Once the building frame is fully sealed, they proceed with installing exterior lapsiding over the wood fiberboard layer. This is the final exterior finish, providing both protection and the defining appearance of the log cabin. The boards are installed in overlapping courses from the bottom upward, ensuring that rainwater is directed outward rather than penetrating the wall. A ventilated gap behind the siding allows air circulation, helping the wall dry quickly after rain and reducing moisture buildup. From a technical standpoint, lapsiding combined with wood fiberboards creates a multi-layer wall system that resists weather while allowing the structure to breathe. This approach improves durability, reduces maintenance, and is well suited for long-term off-grid log cabin living. After 2 years of continuous work, from raw timber to a finished structure, this project has finally come to an end. Every step was built on real experience, time, effort, and persistence. If you found this journey valuable, please like the video, share it, leave a comment, and subscribe to the channel for future projects. Thank you for watching all the way to the end.